Okay, this is section 9.3, right triangle trigonometry. So today, and this is a lot of the most important things about trigonometry is the right triangle trig. This is a lot of what I will do throughout the whole year. And so we have a general strategy. If we have an angle, we're going to put the angle in standard position on the XY axis, and then we're going to make a right triangle. And we will do more of that tomorrow when we do section 9.4. Okay, so whenever you do this, one side of the triangle will have to be the x-axis, and then you will label sides as positive or negative depending upon whether they are x lengths that reach into the positive x-axis or x lengths that reach into the negative, and so on. Then we're going to use the Pythagorean theorem if necessary, and SOHCAHTOA and the reciprocal identities. So today we're mostly going to have these last two bullets because our angles are all going to be, for this section anyway, are all going to be acute angles. And so we only need to be working in the first quadrant, and then tomorrow we'll work with angles and any angles, not necessarily acute ones. Okay, so I also want to mention this detail here. I never want you to give me a trig function without the argument. The angle that you take the sine of needs to be written down because I don't want this sine equals, and I will take off every time I see it. It's the sine of the angle pi thirds that is the ratio radical 3/2. It's a different ratio for a different angle, and you're writing down incomplete and false information, incomplete information when you don't include the angle. So I will be a stickler for that. Okay, and then finally, one other thing I want to mention right here are cofunctions. Okay, so we have lots of cofunctions. We have sine, and its cofunction is cosine. Then you have tangent, and tangent's cofunction is cotangent. And then you have secant and cosecant, right? Okay, so those are our cofunctions. We've got 3 sets of cofunctions. So what a cofunction does is that it's the same answer, there's the same ratio as its function. So function and cofunction give the same ratio when the angles are complements. So this C stands for complementary. So we have complements, complementary angles. And so notice that alpha and beta add up to 90 degrees. And so when I take the sine of alpha, okay, I would label that as, let me call this A and this B. That would be A over B. Let me call this C. That would equal A over C, the opposite over the hypotenuse. And then if I were to do the cosine, not of alpha, but of beta, of alpha's complement, right? That alpha and beta add up to 90, so they're complementary angles. When I do the complementary function, the cofunction of the complementary angle, notice we do adjacent over hypotenuse, you get the same answer. And that's just a nice little thing that comes out. That's why we name cosine cosine and not, some other random name. It's complement of sine. Okay, here's our first example. I'm going to give you part of a right triangle and ask you to evaluate the 6 trig functions at this angle. So, let's make the angle here, theta. So here's a right triangle. I have one leg of length 4 and the hypotenuse of length 8 or 7. We're going to figure out the other leg side. So let me call that A. So A squared plus 4 squared equals 7 squared. So A squared is 49 minus 16, which is what, 33. And so A is the square root of 33. So A equals radical 33. And now that we have a complete triangle, I'm going to ask you to tell me the sine of theta, the cosine of theta, the tangent of theta. We're going to find all 6 trig functions. Also the cosecant of theta, the secant of theta, and the cotangent of theta. Okay, so let's start with the sine. So here's theta. He's in this spot right here. 4 is going to be my opposite. A, or radical 33, is my adjacent, and 7 is my hypotenuse. And so I'm just going to use so, ka, toa. All right, so the sine of the angle is the opposite over the hypotenuse. That would be 4/7. I'm going to go ahead and do the cosecant at this point. Cosecant and sine are reciprocals, and so I know that the cosecant of the angle is 7/4. All right, now let's do the cosine. The cosine is the adjacent, radical 33, over the hypotenuse, 7. And so now my secant is going to be 7 over radical 33. You may rationalize that denominator if you like to do that. That would be completely fine. And a lot of textbooks still do that. I will not do that. I don't see the point in it, so I will not do that. And you don't have to. Okay, and then let's do the tangent. Tangent will be opposite over adjacent, and cotangent adjacent over opposite. Opposite was 4. And that's it. So you're all done there. Okay, and then this is actually our last example. All right, so now we're going to kind of go a little bit reverse. I'm giving you that the cosecant of an angle is 9, and I'm asking you to tell me what the sine is, the cosine, the tangent. You don't have to tell me the cosecant because I already told it to you. Then the secant and the cotangent. Okay, so how do we figure all of these out? Well, I can already figure out the sine. It would be the reciprocal of the cosecant, so that's 1/9. But to figure out the rest, you're going to need to draw your own right triangle. All right, cosecant is the reciprocal of sine, which is opposite over hypotenuse. So 9 is the same as 9/1, and that's going to equal the reciprocal of sine, so hypotenuse over opposite. So now I'm going to go over to my right triangle. I'm going to label the hypotenuse, which is the length, the side across from the right angle, as 9, and the opposite to the theta as 1. And now I have to figure out this side again. I'm going to call him B. Okay, so 1 squared plus b squared equals 9 squared. So b is the square root of 80. Radical 80. Okay. And so now I know the cosine. That would be the adjacent over the hypotenuse. And the secant will be hypotenuse over adjacent. The tangent is opposite over adjacent. And the cotangent is adjacent over opposite. And there you have it.